anybody out there? Is there anybody out there? Anybody out there? Is there anybody out there? I would like to leave this city. This old town don't smell too pretty, and I can feel the warning signs running around my mind. And when I leave this island, I book myself into a soul asylum, 'cause I can feel the warning signs running around my mind. So here I go, I'm still scratching around in the same old hole. My body feels young, but my mind is very old. So what do you say? You can't give me the dreams that are mine anyway. Half the world away, half the world away, half the world away. I've been lost, I've been found, but I don't feel down. No, I don't feel down. No, I don't feel down. Don't feel down. Don't feel down. Don't feel down. Don't feel down.
Welcome guys to the live broadcast of the Firming Space Programme, and we're here with our guest Chris Hillcox.
Good morning. All right.
Yeah, man. Craig, do you want to take the first question?
Okay, can you describe the process of setting up?
Yeah, sure. So what we're going to do today is we're going to take the models that you've created up about 30 kilometres on a high altitude balloon. So the first thing that we're going to do is we're going to make sure that all of the figures are secured to the payload, so we don't want them dropping off, and that's already been done. Then we're going to turn on all of the electronic devices, which are going to make sure that we can actually recover this at the end. So we have a little device here, and that's a little GPS beacon, and that's going to show us on a map where our space probe goes. And if that were not to work, then we've got a couple of little other GPS devices.
So they're basically like backup ones?
Yeah, exactly, yeah. And we've got two of those because we want to make sure that we definitely find this. And there's one that's already attached to the payload, and that uses the radio spectrum to broadcast its location. And then once we've set that up, we'll inflate the balloon. We'll stick about 6 cubic meters of helium in it, which is lighter than air gas. So when we let go,
so we'll go higher.
Straight up. Okay, let's go launch that balloon.
3, 2, 1.
you reckon the sculptures will survive the impact?
Yeah, even though they are fired clay and so brittle, I'd imagine that because they're on a nice polystyrene base, that'll take the impact. And this frame is quite flexible as well.
Okay.
So it's not going to land straight down, boom, like that. It's going to be swinging around like a pendulum. So one of the corners will take the impact, and my guess is that the frame will break before your figures do, which is good news.
Is the balloon reinforced?
It's not, no, and we don't want it reinforced too much because then it would spend a lot of time in the air, and that would mean that it would go past where we want it to come down, which is kind of by a place called Royston. It would carry on going south, it would go over London, and if it was reinforced then it would carry on going and going out into the Bay of Biscay, which would be terrible news.
What part of the atmosphere would it go? The stratosphere, the stratopause, or anywhere between
You gave the answer right first time. The stratosphere. So the pauses are always the boundary layers. So you have the troposphere, which is where we live, and where planes fly, and the boundary is called the tropopause, and then you have the stratosphere, and that's where it'll eventually go to. So it'll go about 30 kilometres high, which is well within the stratosphere,
Okay.
and it'll be very cold there.
Okay.
About minus 50, minus 40, minus 50.
That's cold.
Yeah, that's pretty cold. The air pressure will be really low as well, and that's really good because if the air pressure wasn't low, then the balloon wouldn't expand and eventually burst, and would just carry on rising.